Hi everyone, welcome. So we're gonna explore some Raspberry Pi today, and you might be like a lot of people which don't really know about Raspberry Pi. So what is a Raspberry Pi? So if you look at this picture, um, a Raspberry Pi is a tiny computer. Um, it's much smaller than a laptop or something you might be familiar with, like a tablet. Um, but it's very powerful and can do a lot of cool things. It's just a matter of knowing your way around it. So if you see there's all these little tiny parts on this board, it looks complicated now, but we're going to go through the important ones. For example, the GPIO pins, which you see on the board in the picture now. So the main thing to remember is the board of this is Raspberry Pi is the brain that allows you to do many fun projects. Basically, the limitation is just your experience and your imagination. So these drawings next to the Raspberry Pi and the other side is basically showing how people just like you and me are using Raspberry Pis to build robots, play games, create digital art, all kind of things. There's sensors you can make. They're being used in research labs and companies to build things that are way, way, way more sophisticated. But in the end, they all started the same way as we're going to.
Okay, hi guys, this is a simple video on how to hook up an LED to a Raspberry Pi. So these are the parts you'll need. Raspberry Pi, here I have the 4B. You'll need some jumper cables, the red for power, black for ground, and a resistor, 330 ohms will work for this, and a LED and breadboard. And I'll have below a physical map that will tell me which pin corresponds to which type of outputs. So basically with Raspberry Pi, the big feature that we really enjoy using for this is the ability to do physical computing, which is controlling physical hardware through a computer. So for that, we'll need the GPIO pins. So in general, when we're working with Raspberry Pi, we're really looking to work with the general purpose input-output pins, or GPIO, which you see in this aqua color. So there's certain pins, physical pins on the Raspberry Pi. There's 40 of them, and only certain of them are GPIO pins. So like you can see on the map, it would be pins 11, 13, and 15, for example. Okay, so let's get started with that background. One other piece you should kind of understand before we start is the layout of how a breadboard works. It's basically that every column is physically connected if that column is on the same side of the trench. So there's a trench in the middle of this notch, and if two components are on the same column, they are physically connected. So the current's going to flow through them. But if they're separated by this notch, even if they're in the same column, they won't be connected. The exception to that, and we won't see that right away, but is the top two rows and the bottom two rows, where the flow is going from adjacent holes. So if a component is connected side by side, they are physically connected. And that's a neat way to sort of share power or share ground across an entire breadboard. And we'll see that after I set up the basic LED connection. We'll switch it up. Okay, so with that background, you should have a general feel for the layout and the physical pins on the GPIO, which are shown in this map. So let's get started. So first, you'll want to find the ground. Choosing a ground that's sort of convenient, we're going to choose the physical pin 9, and that's about 5 pins down. So we'll do that. We'll count 5 pins down. Next, what we kind of know from this map that the GPIO pin we can use is 11. It's right beneath it. And we'll place our resistor onto the breadboard. We want to space out the left and right legs. The orientation of it, it can be this way or that way. It doesn't really matter. We'll talk about the labeling and colors in another video, but for now we know that this is 330 ohms and it'll work, and the orientation doesn't matter. So we'll just place it on the breadboard. Connect power to the left leg. Okay. I can sort of rearrange this to clean it up a little bit, moving it down. Now we can connect the LED. So with the LED, just note that one of the legs is longer than the other leg, and that's the positive side of the LED. And in a conventional circuit, the power goes from positive to negative. So we want the power, or the right leg of the resistor, to go into the long leg of the LED. So the right leg of the resistor to the long leg of the LED. So we'll put that in the same column as the right leg. There you go. And finally, we'll attach the ground to the right leg, the short leg of the LED. And that's it. The key here is to understand that there's no way of knowing that any of these components is not working unless you directly connect the breadboard to the power supply. So we're going to do that. And there you go, guys. We know now that none of the components are damaged and that the circuit is wired up correctly, so we can continue on to the coding piece. But what I want to show now, for those that might not be familiar with a breadboard, although many would probably already be, is that you can sort of lay this out in a different way if you wanted to. So remember I said that the top two and the bottom two rows are sort of laid out a little bit differently in how they're connected. So you could actually for example, if you wanted this top row here to be ground, you could attach your ground to this rail, we would call it then. In that case, it would be the ground rail. Now this entire row here is ground. And we could bring that rail down into our circuit. So we attach ground this way. And now when we put in our power, well, again, we'd have to directly test it, which we will do now. We'll see it works that way as well. And so this is just a neat way to sort of share power and ground across components in your circuit. As things build out and get more complicated, you'll see that it makes more sense to share the power and ground through a rail rather than keep adding wires and more wires to your setups. So this is just something to keep in mind.